Keep looking. Good old Dan. A hockey player of mass 72 kilograms is skating due north. You know what? Since I see a compass, I see directions, I'm going to put a little compass rose here because I get that wrong often. He collides with another player of mass 65 kilograms who is skating south at 8.1 meters per second. After the collision, the first player moves off at 1.3 meters per second south. What is the final velocity of the second player after the collision? Magnitude and direction. Is there a collision? Is there a collision?
Yeah.
This is a job for conservation of momentum. The sum of all the momentum before the collision has to equal the sum of all the momentum after the collision. Before the collision, what's moving? Player 1, player 2, or both? Before the collision, what's moving? Player 1, player 2, or both? Stuck together or separate? Momentum 1 initial and momentum 2 initial. Wham! They collide. After the collision, what's moving? Player 1, player 2, or both? Both? Stuck together or separate? Separate. Are any of these zeros? I don't think so. Okay. So it's going to be M1V1 initial plus M2V2 initial equals M1V1 final plus M2V2 final. Okay. And it looks like, Carson, what they want me to find is that boy there. How will I get that by itself? Well, first, I think I need to move this over by subtracting. That will give me M1V1 initial vector plus M2V2 initial vector minus M1V1 final. And apparently that's going to equal M2V2 final. Wait a minute. How could I get the V2 final by itself? What could I do with this M2? I think divide. Okay. I see directions. Spence, I'm going to let north be positive and south be negative. You could do it the other way around, but it kind of makes more sense to me. So, time to plug and chug. It's going to be the final velocity, mass 1, 72. V1, north, so positive 7.5, plus mass 2, 65. V2, south, so negative 8.1, minus mass 1, 72. V1 final, he moves off that fast south, negative 1.3, divided by M2, 65. I like this question, I like this question, I like this question. This is a nice question. There's a bunch of stuff on the top, so I'll put the whole top in brackets. 72 times 7.5 minus 65, minus Mr. Dueck, plus 65 times negative 8.1 minus 72 times negative 1.3 divided by 65, close bracket, divided by 65. You get positive 1.64? 1.64, 64, 65, 65, Mr. Dueck. Round off properly. Meters per second. That's the magnitude. Direction. North. Okay? I guess what happened, player 1 comes up north, player 2 is heading south. After they collide, they bounce in opposite directions. Okay? I can visualize that. Sure, that's a body check bouncing off each other. If you got that, 3 out of 3. Otherwise, I would probably go something like this. I would give you 1 mark for the magnitude, 1 mark for the direction. I would probably give you a half mark if I saw that you had written the sum of all the momentum initial equals the sum of all momentum final. And I'd probably give you a half mark if I saw this magic equation there. Number 2. A ball is dropped and it hits the ground at 8.2 meters per second. After impact, it rebounds upwards. You know what? I'm going to let up be positive, and I'm going to let down be negative. What's the average force? Okay, well, force equals change in... Force times time, equals change in momentum. Impulse. So the force is going to be the impulse divided by the change in time, except I'm going to stop writing the delta in front of the time. Change in momentum, well, that's going to be mv final minus mv initial. It's going to be final minus initial, and momentum is mass times velocity. Kyle's not here, otherwise I'd hit him. What's the mass? Careful, not 52. Grams. So, Spence, I think I read your lips like, did you say 0.052? V final, positive 6.2 upwards, minus 0.052. V initial, negative 8.2 downwards, 0.15. Is there more than one number on the top? Better put it in brackets. 0.052 times 6.2 minus 0.052 times negative 8.2. Close bracket, divided by 0.15. Do you get a force of 4.99 newtons? Oh, that's the magnitude. Direction. Positive. Are you positive? Oh, sorry. Up. Oh, come on, that wasn't bad. Anyways, I would give you probably a half mark for the 4.99, a half mark for the up. I'd probably give you, you know what, 1 mark if I saw that, and probably 1 mark if I saw that. Something along those lines, I don't know. But 3 marks, but if you got the right answer, 3 out of 3. I've never asked you B before. This was to see if you could put 2 and 2 together and get 4. I asked you for the change in kinetic energy. Why, what's change in anything? It's going to be final, takeaway, initial. So it's going to be a half mv final squared minus a half mv initial squared. It's going to be 0.5.052 v final 6.2 squared minus 0.5.052 v initial 8.2. Mr. Dueck, shouldn't v initial, that 8.2, shouldn't it be negative, Mr. Dueck? Because it's down. First of all, energy is a scalar. But also, even if I did put the negative in there, I'm going to square it. What's going to happen to that negative? It's going to vanish, which is one of the reasons energy is a scalar. I'm going to get a negative answer, though, I think, because I think I'm losing energy. 0.5 times 0.052 times 6.2 squared. Take away 0.5, a half, times 0.052 times 8.2 squared. You got a change in potential, a kinetic energy of negative 0.7, I'll go 7.5 joules. What's the negative mean? The ball lost energy. Wait a minute, Mr. Dueck, I thought you said we couldn't ever lose energy. Actually, where did that energy go? Spencer should know this as a basketball player. Heat. The ball's going to get hotter. It's why one of the reasons you do warm-ups before every game isn't just to loosen up your body, it's to warm the basketballs up. Because especially when they come out of the cold or whatever, they're terrible. So what do? You bounce them like crazy, adding extra kinetic energy inside on the air molecules, having them bounce off of each other more. We call that heat. Right? Yeah. You with me? Yeah. Okay. Turn the page. wants me to find the average force. Well, force change in time equals change in momentum. So I think the force is going to be the change in momentum divided by the time. In fact, I think I could probably go like this. Copy. I think mathematically this is going to be the same physics. A car change in velocity is the same physics as a ball bouncing. It's just that I don't think there's going to be a change in direction here. It's going to be mass of the car, final velocity, minus mass of the car, initial velocity, over 8 seconds. I forgot to put brackets, didn't I? So I'll hit equals divided by 8. You get 1,950 newtons? And I just asked for the magnitude because I didn't give you any directions. By the way, what's the acceleration? If I know force, how can I find acceleration? F equals what? ma, divide by the mass. So if I go divide by 1,200, there's my acceleration in meters per second squared. Or I could also have gone A equals VF minus VI. I'm doing some review for you guys towards the end of the year. I could have done that. And watch what happens if I go bracket 25 minus 12 divided by 8. Lo and behold, I get the same answer. I have to get the same answer with both different methods because the physics doesn't change from one situation to another. So we're again at a stage now where we got more than one option. For 2 marks, I'd probably go half mark if I saw that, half mark for that, half mark for that, and a half mark for the answer. A force of 120 newtons acts on a 40 kilogram change in velocity. Well, force, you know what? I think it's the same physics, sort of, except instead of dividing by t, I'm going to leave the t here. What's change in anything? Final minus initial. I can take this and I can rewrite this. This is the same as force times time equals m in brackets v final minus v initial. You learned how to do that in Math 9. You called it factoring using the GCF, the greatest common factor. What's change in anything? So what's final minus initial? Change in anything. Right? What's final minus initial? Change in velocity. There it is. The force times the change in time equals m. And you know what they wanted me to find here, Oscar? The change in velocity. How would I get the change in velocity by itself? How would I get the delta v? Whoop, didn't want to do that. How would I get the delta v by itself? More specific. Divide by m. So the change in velocity is going to be the force times the time divided by the mass. It's going to be 120 newtons times 8 seconds divided by 4. I should be able to do that in my head. Is the answer 240 meters per second? Divide by 40. Is the answer 24 meters per second? So what does that mean? It means that if you started at rest, after 8 seconds, you're going 24. If you started at 2 meters per second, after 8 seconds, you're going 2 plus 1, 26. If you started at 30 meters per second, after 8 seconds, you're going 30 plus 24, 54. I just know that the change in velocity was 24 meters per second. 1, 1. I don't know. You can give yourself part marks along the way. I like number 5, I like number 5, I like number 5. I see directions here. So, when suited up in his hockey gear, George weighs 65 kilograms. He's skating, you know what? I see this word here, collision. This is a job for conservation of momentum. The sum of all the momentum beforehand equals the sum of all the momentum afterwards. Before the collision, what's moving? George, Jim, or both? Both. Stuck together or separate? Mass 1 V1 initial plus mass 2 V2 initial. This time I skipped a step. I didn't actually write the P1 initial, P2 initial. I just went straight to mass V1 initial. So if you feel comfortable, you can do that. Knock, knock. Knock, knock. Bam! They collide. After the collision, who's moving? George, Jim, or both? Both? Stuck together or separate? I think separate. Okay? So it's going to be M1 V1 final plus M2 V2 final. Let's call mass 1 George, mass 2 Jim, and it looks like we're trying to find that. You know what? This is exactly like number 1. I'm going to minus that to that side. That's going to give me M1 V1 initial plus M2 V2 initial minus M1 V1 final. And I'm going to divide by M2 to get the V2 final by itself. Plug and chug. V2 final is going to be mass 1, 65. V1, I'll let east be positive, 12, plus mass 2, 85. V2 west, I'll let that be negative, negative 7, minus mass 1, 65. V1 final. Afterwards, still moving east, positive. All over M2 85. Bracket 65 times 12 plus 85 times negative 7 minus 65 times 4 divided by 85. I get negative 0.88. So I'm going to write this, 0.88 meters per second. What's the negative telling me? Direction, which way? West. Or you could say negative 0.88 meters per second, I guess, but let's put a direction in there. West. And I would probably go half mark for that, half mark for that, half mark for that, half mark for that, half mark for the magnitude, and a half mark for the direction. Can you give yourself a lovely score, please, out of, count 'em, 14? Ready? Here we go. Lesson 0, review of trig. Find the length of the missing side. How can I find the length of that mystery side x? It's a right triangle. Jordan. Lesson loud.
A squared plus b squared equals c squared.
What's that called? Okay, we use a squared plus b squared equals c squared. And with Pythagoras, Amy, there's only one thing that you have to memorize, but this is the one thing you do have to remember. I can't put anything where the C is. What side always has to go where the letter C is? The hypotenuse, the long side. Okay, the long side. Most common mistake I see, Kids always want to put the x there. Actually, no, the x is on a short side. Here, the equation is going to look like this. X squared plus 55 squared equals 73 squared. But hopefully now we've done this enough that I say to you, now what? How would I get the x squared by itself? Not yet. Minus 55 squared from both sides. I'll have this. X squared equals 73 squared minus 55 squared. By the way, you could have done both those numbers on your calculator, but it's actually less writing it to write it that way. I know I'm going to type it into my calculator eventually, but I can track things a lot better and I'll make a lot fewer mistakes. Now what, Colin? How to get rid of an x squared? Cross out the squared, put this whole thing inside the square root. The squareds and the square roots do not cancel. I'm going to go on my calculator. 73 squared minus 55 squared square root, and by a wonderful fluke this works out evenly. 48 centimeters. Is that okay, Justin? This is actually one of the first formulas you learn. I think you guys do this way back in Math 8. It's a nice one because it's kind of alphabetical. A squared plus b squared equals c squared. It flows. It's actually really handy. A lot comes out of this, it turns out. So, find the missing side on your own. I'll do it up here. I don't think this one will work out evenly. Example 2. Yeah. 17.7? Okay. Example 3 is cool, but in the interest of time, I'm going to nuke it. So you can find missing sides with Pythagoras. Then in Math 9 and 10, you learn that not only can you find a missing side if you know two sides, you can find a missing side if you know one side and an angle. And this is where we start bringing in this notion of opposite and adjacent and hypotenuse. So label the following triangle. If this is my angle, this side right here, opposite, adjacent, or hypotenuse. Let's put a little h right there. What about this short vertical side? Opposite, adjacent, or hypotenuse? Adjacent means touching, means beside. Opposite, right now Oscar and I are opposite each other. We're facing each other, across from each other. There's your opposite. Don't write this next bit down, but Oscar, what if instead I was talking about this angle here? What would change? Would the hypotenuse change? Would the opposite change? And the adjacent change? They would swap places. Okay? I tend to, if I want to show you, Jordan, which angle I'm using, I'll usually just kind of color it in, or I'll put a hash mark. That's the least amount of work for the best bang for your buck. We also have 3 primary trig ratios on your calculator. What are they called? Sine, S-I-N-E, abbreviated S-I-N, pronounced sine, not sin. Sin is when you don't do homework in my class. Sine is the trig function. Cosine, abbreviated C-O-S, pronounced cos or cosine. And tangent, abbreviated tan, what many of you did this weekend at Pitt Meadows Day. No, tan is the trig function. So you need to be able to use your calculator. Can you, on your calculator, find the sine of 42 degrees to 4 decimal places? And I also do this because some of your calculators might be in a weird mode. You should get 0.6691. If you don't, your calculator is in the wrong mode and we need to fix that. So can you try that, please? 0.6691. If you didn't get that, you want to raise your hand and ask. Did you get that? Justin, you got that okay? Yeah. Everybody's in degrees? Okay, if you got that, can you find the cosine of 76 degrees, the tangent of 45 degrees, and the tangent of 90 degrees, please? Cos 76 is 0.2419, blah, 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 blah. By the way, most trig functions, unless they work out evenly, like tan 45, if they have decimals that repeat, if they have decimals that go on forever, they're like pi in that they're irrational numbers that go on forever. Tangent of 90 is undefined. Hey, what's the tangent of 89 degrees on your calculator? Can you try the tangent of 89 degrees, please? Does that work? What's the tangent of 89.9 degrees? Bigger, smaller, or the same as 89? You know what? Let's try 89.39. What's that? Bigger? What is the tangent of 90 degrees? In calculus, we say it approaches infinity. The more nines you add, the bigger and bigger and bigger and bigger and bigger the number you get, but it's not defined. The tangent of 90, it's infinity. If you really wanted me to pick a number to describe it, but infinity is not a number, it's a concept, so it's undefined. But, nerd trivia. We can also use our calculators to go backwards. Not only can my calculator give me the sine or the cosine or the tangent of any angle, I can give it the sine or the cosine or the tangent and say, what's the angle that it came from? So if I told you that the tangent of, and we have a tradition in math, the variable that we often use for an angle is the Greek letter theta, which is 0 wearing a belt. Why? Well, the same way as when I see an X and Y, I think graphs. The same way as when I see an ABC, I think Pythagoras. When I see a theta, I think trig. If the tangent of theta worked out to 3.732, what's theta? How do you go backwards on your calculator? This is going to vary from calculator to calculator. On mine, because I have a good one, I go second function tangent, and mine automatically opens up a bracket, 3.732 close bracket equals. If you have a crappy one, you might have to go 3.732 second function tan equals and do everything backwards, which I hate. I don't think it's 74.999. Where did I start with? 75 degrees, and then I rounded off my tangent answer, 75 degrees. So, in example 5, can you find the missing angles if the sine of angle A is 0.5? What's angle A? If the cosine of theta is 0.5, what's theta? If the tangent of theta was 0.4877, can you use your calculator right now, which you have out in front of you, yes? Where's your calculator?
No, it was in my bag.
Ooh, you have to figure this out later. Go backwards, please. Now, I'm lucky. I have some of these memorized. I'm pretty sure this one is exactly that, yes? And I'm pretty sure this one is exactly that. C, I have no idea. $26 degrees? Yep. You need to know how your specific particular calculator works for trig. And if we put it all together, we had this. We had the definitions, turn the page. I think, is it turn the page? Yes, it is. Of sine and cosine and tangent. We defined sine of a triangle as the opposite side divided by the hypotenuse side. The cosine of a triangle was the adjacent side divided by the hypotenuse, and the tangent of a triangle was the opposite side divided by the adjacent side. And we gave you this acronym of SOHCAHTOA, which told us what? Well, it told us if we know any two things, I can find the third. Example 6 says, determine the length of the indicated side. Okay. Here's how we handled these. First of all, we did have to ask, is there a right angle? Because if there wasn't a right angle, SOHCAHTOA doesn't work. Is there a 90-degree angle? How do I know? That's what the little symbol means in the corner. Okay. So which angle did they give me? The 57? You know what? I tend to put a little hash mark there just to draw my eye there. And then I label the sides. I do not label all three. And I know many teachers teach you to do that. I think, Colin, that's more work and more confusing. I'll show you what I mean. That x, opposite, adjacent, or hypotenuse. Put a little O there. That 15, adjacent or hypotenuse. Put an H there. What two letters are on my triangle? O and H. Which trig function has the O and H in it? Now, some teachers will tell you, oh, label that one. Can you see by doing that, now you have another letter to confuse you. Now there's a risk you might pick cosine or tangent. If you never bother labeling it, in other words, Max, if you do less work, I think it's clearer. So I never label the blank side unless it turns out later that I need it. Just a little trick of the trade. Which trig function, Spence? Sine of what? What always goes next to the trig function? The angle. What always goes next to the trig function? The angle. What always goes next to the trig function? The angle. 57 degrees equals opposite over hypotenuse. How would I get the x by itself? On your calculator, can you go 15 times the sine of 57? By the way, look up for 1 second. Don't write it like this. Just because your calculator, I don't know how all of your calculators work. Some of your calculators might do that first and then take the sine, which is totally not what you mean. So develop the habit of putting the number in front of the trig function, sort of like you put a number in front of a variable, like a coefficient. It's going to be 15 sine 57. Oh! Delete. 12.6. Is that right? Units, centimeters. B. There's my angle. This 11.1, opposite, adjacent, or hypotenuse. What about this x? Which trig function? Tan, what you do in Hawaii? Unless you're Jordan. Tan of what? What always goes next to the trig function, the angle. And it's going to be opposite over adjacent. Hey, where's the x this time? Yuck. Wait a minute. How could I move it to the top? The x is on the bottom. How can I move it to the top? Or let me say it this way. What's this x doing to the 11.1? Dividing. How could I move this x to this side? You know what? That is the same as that. Same equation. I wrote it differently, but the same equation. And why is that so much nicer? What's happening right here between the x and the tangent? Timesing. So how will I move the tangent over? No one noticed. So if I hear you correctly, Spence, you're saying x is going to be 11.1 over tan 28. And these are going to be the two main types of trig equations you're going to get. You're either going to end up, like in this one, going the side times the trig function, or like in this one, going the side divided by the trig function. Those are the only two possibilities. $20.9? $20.9 centimeters. Not only can you find a side, you can also use this to find an angle. Find angle x. I'm going to start out exactly the same way. Am I wrong, by the way, on the last question? I see people staring. That's right? 20.9? Okay. I'm going to start out on this one, Amy, exactly the same way. What was the first thing I did on my previous two questions? Even before I labeled the sides, what did I do? It takes 1 second, but I'm telling you, that cuts down on a lot of your side mistakes. I don't know why, but it does. Now, I'm going to label two sides, not three, just two. What's that 12? Opposite, adjacent, or hypotenuse? Sorry, there's no 12. What's that 15? Let's try that again. What's that 15? Opposite, adjacent, or hypotenuse? What's the 7? Adjacent. Which trig function has an a and an h in it? Cos. So we write cos. What always goes next to the trig function? The angle. What's the angle this time? Is it a number? No. Is it a letter? Okay, no big stretch. That's the variable. Equals adjacent over hypotenuse. How do we do this? Now we're being asked to find an angle. Oh, we did that a couple of questions ago. How did we find an angle? What did we do to find an angle? This is going to be our shift button. Now look up. Here's the only thing you're going to have to be aware of. If you have a good calculator, it'll do this for you automatically. So it's going to be shift cos. Since it's 7 over 15, if you don't have a bracket open automatically, you will have to hit bracket 7 divided by 15. Otherwise, your calculator won't know that you want to go the shift cos of that whole thing. If you just go shift cos of 7 over 15, I don't think you'll get the right answer, because the correct answer is 62 degrees. I'll pause and see if you can get that. There's the symbol for angle. The symbol for angle is actually an angle. Angle x equals 62 degrees. To the nearest degree, yeah. Mr. Dueck, since we did this on our calculator, how much work do I need to show you? The ratio and the answer. And honestly, the same here. If you can go straight from the ratio to the answer, I'm good with that. I think that's actually being good at trig, not bad at trig. One line is my minimum in all, but honestly, Kyle, I kind of think it was cool if one line was also my maximum. If you can write the trig ratio down, sine or cos or whatever, equals whatever, and go straight to your calculator and get the right answer, I'm totally good with that. B. Thomas, what angle do you want me to find here in B? What angle do they want me to find here in B? Because I asked you to. Why? Because I asked you to. You walked right into that one, Tom. Okay, so I'm going to start out, just take 1 second, color that in. Thomas said cosine. Is he right? Let's find out. Thomas, my friend, this 8.1, opposite, adjacent, or you know what? Actually, let's do the 14.5 first. Opposite, adjacent, or hypotenuse. Just first of all, the 14.5, opposite, adjacent, or hypotenuse. It takes 1 second to write that. This is good bang for your buck. What about the 8.1, opposite or adjacent? And so with conviction in your voice, yea, with authority in your voice, which trig function are we talking about? Sine. Absolutely. This, and this, Thomas, take less than a second. It's some of the best bang for your getting rid of dumb mistakes buck out there. So I strongly encourage you to label it. Which trig function? What always goes next to the trig function? The angle. What's the angle this time, Thomas, my friend? He can be taught. Equals what over what? Opposite over hypotenuse. 8.1 over 14.5. Bracket 8.1 over 14.5. Do you get 34 degrees? Angle y equals 34 degrees. What's your homework? Trying to give you lots of time to both get the homework done and also do a little studying for momentum. All of number 1, Pythagoras. 2 is good. 3 is good. For some reason, there's 2 2s. You can cross off D. You can cross off F. Okay. 4 is good. 5 is good. 6 is good. I'm going to skip the word problems for you guys. So cross off that and that. Tougher questions. Part 2. See if you can get number 1. Your hint in number 1 is you're going to have to hopscotch. You're going to have to use something to find something to get something. But you can nuke number 2. Okay? You got the rest of class.